Hello, my name is Gulam Kadir Parvez and I am from the cohort crawl batch. This video is regarding end course Capstone project module 2. In this project, I am going to explain questions, 5 coding problems from the 25 coding problems. So the first question I am going to explain is from the code bug fixing session. Code bug fixing. So the first question is power of 2. Here the given code is incorrect which has an error and I have to find the error and give the solution. So in the given code there is a logical error. The each power of 2 function is intended to check whether a given number n is a power of 2, but the condition in the code is incorrect. To fix it, I should be checking if the number is greater than 0 and if it has exactly one bit set to 1. So here is the corrected code. In the corrected code, first of all I am checking if n is greater than 0 here to ensure it's a positive number, and then I am using the bitwise AND operator and to check if exactly one bit is set to 1. If the result of the bitwise AND operator is 0, it means there is only one bit set, indicating that the number is a power of 2. The second question I am going to explain is also from the code bug fixing section. Question number 4, sort people. So here is the given code which has some error. So I have found the errors and given my solution without the errors. So first of all, what I have did, I have removed the here heights dot length. Here is the parenthesis after that. So I have removed it height dot length to correctly get the length of the array. And the second change I have did in the for loop condition. Here it is given I is less than equal to length, which is incorrect. So I have fixed in my code. I have did it, I is less than length to avoid going out of the bound. So this should fix the error in my code and it should work as expected to sort people by their height while preserving their names. The third question I am going to explain is from the improvised perspective to the coding problem. So here is the given solution and I have to rewrite the above given JavaScript code using the two pointer approach. So I have written my solution here and I am going to explain it. So the first of all I am checking here if n is a negative number. If n is a negative number, the function immediately returns false because the negative number cannot be palindrome. After that, I have created two variables to keep track the original number and the reverse number. Here, original is initialized with the original number n, so you can compare it to the reverse number later. And the reversed is initialized as 0 because it will store the reversed version of the number. After that, here I am initializing a while loop. This loop runs as long as n is greater than 0 here, which means it iterates through the digit of the original numbers. Last digit here. Last digit extract the last digit of n using the modular operator. This digit is then added to the reverse number after here reverse number after shifting its digit by multiplying it by 10. N is updated by removing its last digit using integer division mat.floor n by 10. As the loop iterates, it accumulates the reversed version of the number in the reversed variable. After that, I am checking if reversed number is equal to the original number here. After the loop, the function compares the original number to the reversed number. If they are equal, the function returns true, indicating that the number is a palindrome. Otherwise, it returns false. The fourth question I am going to explain is from the logic building coding question, which is question number 11, find peak element. So here I have written my solution. This code uses a binary search algorithm to efficiently find the peak elements. So I am going to explain step by step the code. So first of all, I am initialize two pointer here, left and right, to define search range. Left start at the beginning of the array at index 0 and right start at the end of the array, which is equivalent to the last index. After that, I am using a while loop to perform binary search within the array. Inside the loop, a variable mid is calculated here, which is indexed halfway between left and right. This index represents the middle of the current search range. Check if the here check if the middle element nums mid is greater than its neighbor to the right. If num mid is greater than nums mid plus 1, it means there is a peak on the left side of the mid index and the right pointer is updated to mid. Effectively, the search range to the left subarray. If num mid here after that, if a num mid is less than or equal to num mid plus 1, it means there is a peak on the right side of the mid index and the left pointer is updated to mid plus 1, narrowing the search range to the right subarray. The loop continues until the left and right neighbors meet, which happens when the search has been narrowed down to the single element. This single element is a peak because it's either greater than or equal to its neighbors. Finally, the function returns the left pointer, which point here, which point to the peak element. And the last question, question number 5, is I am going to explain is from the analyzing traditional approach versus optimized approach, which is question number 17, duplicate check. So here two solution is given, traditional approach and another from optimized approach. So I have provided my comparison here, advantage of the optimized approach. So first one is time complexity. The optimized approach is considerable faster due to its linear time complexity of O of n, whereas the traditional approach has a quadratic time complexity of O of n square due to the nested search operations. The second is simplicity. The optimized approach is more concise and easier to understand. It leverages built-in JavaScript features, making them more readable and maintainable. The third is efficiency. Using a set for deduplication is more memory efficient than repeatedly searching through the temporary string to check for duplicates, especially for the large string. The fourth one is maintaining order. The optimized approach preserves the order of the character as they appear in the input string, which may essential in some scenarios. The fifth one is reduce code complexity. The optimized approach reduce the need of manual indexing and conditionals, simplifying the code and making it less error prone.